Right, this graph relates from all the way from 9 to 11, so I'm just going to answer these one at a time. A graph of a thermistor. Alright. What is the resistance when the temperature is 5 degrees of the thermistor? This is an easy one marker to start with. So 5 degrees is here. You go up here and we get 5,000 ohms. The next question, I've just copied and pasted these onto one page so it's easy to see. It's the same graph, and they've given us that the thermistor is incorporated into a circuit to control an air conditioner. The circuit is shown here. The electronic switch activates the air conditioner on when it reaches 8 volts. So this thing here measures the voltage over here, and when it measures 8 volts it turns on. The air conditioner wants to come on when it's 25 degrees. What resistance should the variable resistor be? Now, first mistake before we even start this is that some people use the 5 degrees from the previous question, where it was 5,000 ohms. New temperature, 25 degrees. Got to read each question carefully. I'm going to do my working on here and then make sure I've got enough working here to get the marks. It's easier to understand here, but we've got to make sure this is where the actual working is. Alright, so this is 12 volts total, 8 volts over this variable resistor. How much does it leave for the thermistor? 4 volts. Because 12 minus 8 equals 4. The thermistor is the one that measures temperature, 25 degrees, which is here, and which is here. We come across and we get that point there, 500. So, which of these is 500 ohms? It's the thermistor. That graph is for the thermistor, 500 ohms. Now, the ratio of 4 to 8 is the same as the ratio of this resistance to this resistance. I.e., 8 is twice as big as 4, so this is twice as big as 500. The answer must be 1,000. That's the answer. We've just got to make sure we put enough work in to get our 3 marks now. I'm going to say at 25 degrees, the thermistor equals 500 ohms. 8 volts over variable, therefore 4 volts over resistor of the thermistor. And the last dot point is ratio of resistances and voltages same series. That's what I was talking about when I was saying 4 to 8 is the same as 500 to 1,000. So we say 4 volts to 8 volts is 500 ohms to something ohms. Therefore, variable resistor equals 1,000. And the last question in the set, again I've just copied and pasted everything up to the top so I can refer back to it. The air conditioner wants to now come on at a lower temperature, and before it was going on at 25 degrees. Should the variable resistor be increased or decreased to achieve this? Right, increase or decrease in the box provided. When I do these questions, it's easy for me to go through the working first and then write my answer at the end, because I don't know what it is yet. So let's go through the working. Now this is how I'm going to go through this working. It was getting turned on at 25 degrees. It now wants to go on at a lower temperature. So let's choose a lower temperature. It's easy when we've got numbers. So let's choose 10 degrees. If we go 10 degrees, the thermistor is 2,000 ohms. So, once on at low temperature, assume, for argument's sake, on at 10 degrees. So thermistor equals 2000 ohms. Right, the air conditioner still turns on at 8 volts, so ratio of resistances must be maintained. What I mean by that, let's show you maintained on this drawing here. This still wants to turn on at 8 volts, still does that, therefore this still has 4 volts. Okay, 8 and 4, one's double the other. This now has 2000 ohms. 8 is double 4, what is double 2000? This now has to be up to 4000 ohms. So in this case, variable will increase to 4000 ohms, because it was originally, in our last question, it was a 1000 ohms. So we can write our increase up here. So we did the working for this first, bit of working on my diagram as well. Write it all down here, nice logical dot point order. After we've done our working, we realise what the answer is, so we can put the answer up the top.